6.12. Determine the forces in members DC, HI, and JI of the truss. State if the members are in tension or compression. Suggestion: use the sections shown. So DC is right here, HI is right here, and JI is right here. At first glance, it looks like cut T goes through all of them. And it does, and as the text suggests, we should use that. However, cut T is not going to be enough, because cut T goes through 1, 2, 3, 4 members, which means that even excluding reactions, that is 4 unknowns. Now the text also suggests cut S, which does this kind of loopy cut. And you are allowed to do that. As long as the cut is a continuous line, you're allowed to curve it, bend it, however you want. So I am going to start by looking at cut S. For cut S, and looking at this top section of the truss, there are these two load forces downward. There is HI, CD, DJ, and HJ are our tensions. Furthermore, in the X direction, these two members are the only forces. The load forces are straight down, and there are no reaction forces on this top subsection. So our sum of forces in the X direction becomes TDJ minus THJ equals 0. In the Y direction, we have these two load forces and these two tensions. So that becomes negative TCD minus THI minus 1,200 and 1,600 or minus 2,800 pounds equals 0. Finally, for moment, I selected point H. That would eliminate the tension in H. It would also eliminate both of these tension forces, since tension HJ is acting at point H, and even the tension DJ is acting along that line of action, which means the only unknown force would be tension in CD. Again, using the standard that clockwise is negative and counterclockwise is positive, and again using the standard that all beams are in tension, that says minus 12 feet times TCD minus 21 feet, 6 plus 6 plus 9, times 1,600 pounds, plus 9 feet times 1,200 pounds equals 0. Now, there are 4 unknowns in these 3 equations, which means we can't solve everything. But using the sum of moments in the H direction equation, we can solve for tension in member CD. And then using tension in member CD, we can solve for the tension in member HI. So we can solve for 2 of these. And CD and HI were 2 that we wanted to find. Now we cannot know what TDJ or THJ are, but we can know that they are equal to each other. So next, I decided to use this middle section right here. This section is solely composed of joint J. Now, you are allowed to do this. Keep in mind that if you have a section that is composed of a single joint, you are basically applying the method of joints there, which means that you will not have a sum of moments equation. However, in the X direction, or in the sum of forces equation will be sufficient. So in the X direction, there is HJ and DJ. There is also the X component of IJ and CJ. put them all together, CJ and IJ are at angles. DJ and HJ are horizontal. And so you get this equation here. In the y direction, HJ and DJ are both horizontal, so they won't apply. So you only have the y component of CJ and the y component of IJ. Now there's something curious going on. X components use cosine and y components use sine. But if we look at the geometry, this angle and this angle right here are 45-degree angles, which means sine and cosine are equal. Also recall that DJ and HJ had the same tension, so I could take these two terms and they would cancel out. And so my sum of forces in the x and y direction, in x, this says that CJ must equal IJ, and this one says that CJ and IJ must add up to 0. Well, there's only one value that they can each be that will satisfy these two conditions. Both CJ and IJ must be 0. These two must be zero force members. Now, we still haven't solved for HJ or DJ, but it turns out that doesn't matter because the question asked about CD, HI, and JI, which we have solved. CD is 1,900 pounds compression, HI is 900 pounds compression, and JI is 0.